Okay, so welcome back to the QEEE session on operator overloading. Yesterday we looked at basic operator overloading, and we came to know of some of the restrictions that are imposed on overloading operators in C++. However, there are a lot of flexibilities which are given, and suddenly your code might become more readable as you appropriately use operators and overload them properly. So towards that, so we'll go ahead and discuss further on other operators which are possible to be overloaded in C++, and what is the syntax and what are the implications of each of them, and what can you do with operator overloading in general. So we were here, and what we were looking at is that we had, as an example of binary operator overloading, we had overloaded the left shift operator, and we said that in general, whatever operations you can do on an integer, let me see if those operations can be done in a class which is encompassing, let's say, a number or an integer. For example, left shift operator, if it is not defined for a floating point number, right? Let's say it's defined only for integers, but you want it to be defined for floating point numbers. Maybe you can implement it as a class, and on that class you can implement all these left shift, right shift operators, or even otherwise binary operators in case you require. So we took the example because the left shift operator is already overloaded for OStream, right? So the cout object that we use is an instance of OStream class, and we also want that variable of our own user defined type we should be able to print using cout. However, there were some issues. For example, for achieving that particular aspect, cout class, that is OStream class, need to know our user defined type, which is not always possible because it's a standard library class, and therefore we said that somewhere we'll have to specify this operator overloading in a different manner. It cannot be as part of the class. So that was the second point which we were talking about, that you can, if you have a flexibility of implementing a left shift operator inside the OStream class, well, you can possibly do that, but there exist better ways in which we can do it, because you cannot arbitrarily do it for any number of user defined classes. So I'm now going to slide number 15, and you'll see a lot of code, and yesterday I got some feedback that this code is turning out to be very small. So I'm planning to use board more often today as far as examples are concerned. So this example is essentially talking about how do we overload left shift operator for a particular class. So we had hash include IOStream, which is the header for input output stream operators and functions. For example, cin and cout. And then I have a class which is a user defined class. In this case, I'm calling it as num because it is representing something related to numbers, right? So we'll fill that up a little later, but let's assume that there is some public method, let's say, okay, let's fill that up right now itself, get num. So it's a getter method which returns something, let's say return num, return n, where n is a local variable of this class, so which means that there is a private, let's say int n, right, which is what is being encapsulated as part of this num class, right? And then I also need probably a constructor which should be public, to which if I am passing some variable, then I am initializing n with that variable. Right? So this is our num class. So there is no overloading as far as left shift operator etc. is concerned so far. Now let's talk about main. So I'm going to write main this side so that we'll be able to see both of these. So I'll probably write the operator here. So our main function is essentially going to create a variable of that type, let's say num n1, right? And I need to, since num has a constructor with an integer as a parameter, I can initialize it with, let's say, 5 as the parameter, right? And then what I want to do essentially, this is the important part, that with cout, I want to print n1. With cout, I want to print n1. Cout doesn't know about the type of n1. N1 is of type num, which is my user defined type, right? And then maybe return or something. This is our main, which is going to make use of this num class. So the variable n1 is of type num. Now what is missing is this link, that how do we connect this cout, left shift operator, and this n1, which is of type num, right? So that is where operator overloading comes into picture, which is going to be outside this class now. So what I am defining is an operator left shift, right? The same syntax as we had earlier, which takes what? It takes not only n1, since it is outside any of the classes, it should take 2 parameters. So it's a binary operator, so it should take 2 parameters. One is the ostream and another one is the num class, right? So there is an ostream, std : ostream, maybe a reference to that, and so this is an operator which takes 2 parameters. It's a binary operator, right? So therefore it requires 2 parameters. And what you do inside is essentially you just use standard cout. This left shift is now going to be using the variable n, which is of num type, but I'm going to invoke get num on this. Get num. So okay, so we should not be using std. So we can actually use std cout, but what we want to do essentially is to return that. Okay, so we'll come to that. But and then there is something which is probably missing here, which we'll fill up later. But and also the return type of this. But the purpose of this one is that the left shift operator now is the original that was on num with ostream and num as the 2 types is now converted, or it is using the left shift operation, which is using n.getNum as the argument. And what is n.getNum returning? It is of type integer. Is cout defined for integers? Yes. So we are making use of that existing functionality. So when ostream class was implemented as part of C++ STL, this cout was implemented for int, and that's what we are making use of to get it implemented for the num variable type. So in general, this much suffices. For example, you can actually make it return here, and this can be void, right? That is possible to be done. However, what we also want is that essentially I should be able to say num n1, n2 and so on, right? So you can have a chain of multiple arguments that you can pass. For this to happen, again we need to worry about the associativity of left shift, which is left associative. So this part should return something on which I should be able to apply the left shift operator, and that is possible to be done only if this part returns ostream's reference, and therefore it should not be simply this. If you want a chaining, and it cannot be void, it has to be of type ostream ampersand, that is a reference to ostream, and you might have to qualify it if you are not using using namespace std. And what should it return? Right? So the return should be whatever is the parameter that you have passed, return that stream. So a reference to that gets returned, which can then be returned by this part of the cout, and on that ostream object, which is again cout itself, n2 gets invoked, where n2 might be another whatever here I can say n2 of 3 or something. Right. So in general, you can associate multiple such left shifts, and it's not necessary that the two arguments that we have passed here to multiple left shifts should be of the same type. You are just returning cout here, and on cout you can have integer, character, num type, whatever for which the left shift operator is defined. Right? So note that this is outside any of the classes, and we are going to require we don't need to really get inside this class, and in fact we won't be able to do that here as well. Right? So this is one method of implementing left shift operator such that I'll be able to print a user defined type. Right? Contrast it with Java, where you can say that so in case of Java, let me put it this way, where I have system.out.print or println n1. Let's say n1 is of this type. In such cases, the nice thing that Java does is that instead of you need to define an operator like this, it automatically calls a specific method of this class, which is in this case a toString method. And then it's up to you how you define the toString. So that object needs to be converted to some string type, which is up to the implementation of that particular class's implementer, that I want to convert this object to a string or whatever is its type you want to be, and that toString method is going to get called, which is going to get printed finally by the system.out.println method. Right? That is specific to Java, but the way it gets handled is a little different because Java does not have operator overloading concept. Alright, so this particular aspect of C++ or the operator, the left shift operator that we overloaded for input output, in this case specifically the output, has used a specific concept, and that was probably very implicitly used in this case. And that was that we used n.getNum in our example. What does this give you? That gives you some information about this class. Whenever you want to print n1, essentially you want to print what is the number that is stored inside. So this number I could get by applying a method getNum, so this operator is defined outside the class. So the class might be implemented by someone else. This implementation is happening somewhere else. And I am using this getNum as an API from this particular num class, through which I am going to see some of the values that are stored inside this num class. However, if the implementer of num class does not give this function, will I be able to still make use of such a flexibility, right? So in general, this is not possible. So for example, one way of, so I might say that if this function is not there, this getNum function is not defined, will I be able to do something like this? n.n, where this first n is the n as an argument of type num, whereas the .n is essentially the private variable of that particular. So if there is confusion, maybe I'll change it to n5, and I'll say n5.n, right, where n5 is the num and .n is referring to the private variable. Will you be able to do that? If you try compiling this program, you will get a compile time error that, and you might want to just post it on the question tab what the error could be. The error that is going to come here is essentially going to be that this .n that you are referring to is a private variable. This function or method, this function that we are talking about, or the operator, is not part of this class, and therefore this function does not have access to this private variable, in which case you are going to result into a compile time error. How do we solve this problem? Because in general you might not have all of this defined. So how do we solve this problem? That we will see in a while. So we'll go ahead with our discussion on what to do with respect to supporting these methods when the variables are not publicly available, right? So this if you want to relate it to real life, what happens is that sometimes we are not ready to share some information which is probably very personal with everybody, right? You don't post everything that is happening in your life on your blog or on your Twitter or somewhere else, right, on your web page. However, there are close friends with whom we share the information, right? A similar concept is used in C++, that there is a notion of called as friend functions, right? So friend functions and friend classes, where we say that in general when we declare a variable as private, then that private variable is accessible only to the objects of this particular class, right? Only the instances of that particular class, only the methods that are defined for that class. However, if a certain function or a class is defined as a friend function, then that friend is able to access those private variables, right? So this is a concept which is used inside C++. So there is a notion of friend functions which will help us solve this problem. So how does this solve the problem? Let's see. So when we say that n5.n is not accessible inside this operator, it essentially means that this particular class and this particular operator are not friends of each other. These are like arbitrarily away people, let's say on a social network. However, if I can connect these two, then I can allow this operator to access the private variables of this type num. Right? So essentially this operator wants to access this n. The num variable, if it declares, if the num type, if it declares that this operator is my friend, then that is going to be, then this operator is allowed to access this n5.n. Right? How do you declare that? Well, it's essentially very simple. For example, you just say essentially the signature of std : o stream ampersand operator left shift, which takes this o stream as an argument as well as num as an argument. This is a signature of this operator left shift, right? So you put that signature, but that doesn't convey that it is a friend. So what you need to do is that I'll just erase this part now. So that doesn't, it's just a declaration of a function, right? So we need to convey explicitly that it is a friend. So you just say that this is a friend. So once we add this, so friend is a keyword in C++ where to any signature of a function, you just add this friend inside the class to which you want to make it. So why inside the class is something which you should think about, that this class is implemented by somebody else, right? This operator is implemented by somebody else, right? And now they want to talk to each other. This is possible. So this operator says that, hey, I want this particular functionality to be implemented. I want access to this private variable. Either give me a getNum function or give me access to your private variables, right? And so this the person writing this operator is going to talk to the implementer of this, and the implementer is going to add this particular line to this particular class which was implemented by a different person. So this class should say that this operator is my friend, right? It should not be, for example, outside, which it doesn't make sense because the friendship has to be defined inside that class. If we do that, then this function will be able to access the private information of the num class. So n5, which is of type num, dot n is going to refer to this private variable, and this will be allowed by the compiler. And even if that getNum doesn't exist, your code is likely to work, right? So in many of the places, what you will, whenever you ask this question that when I want to implement the left shift operator for cout or the right shift operator for scene, the answer is, oh, make it as a friend function, right? If you notice that it is not really necessary that you should have it as a friend function. If whatever information you want to print, if it is available via the public API, then you don't really need to make this as a friend function, right? So when we had getNum, we really didn't get into the friend functions at all, right? Only when such information is not available via publicly accessible methods, then only you need to get into this private information which needs to be accessed via the friend functions, right? So that's what we will see on slide number 16, where we have, so on slide number 16 I'm showing that error that you can have num.n, in this case n5.n being accessed, and that is going to result into a compile time error. The error is operator left shift cannot access private member n. So on slide 17 we have the solution which we have essentially written down here, where there is a friend keyword and then the operator left shift defined, which is going to essentially tell the world that, or tell the compiler that this operator left shift is a friend of num, and therefore operator left shift is allowed to access private variables of type num, right? All right, so that's essentially what we want to see with respect to the overloading of left shift for cout. So note what we have done is that we have taken care of not really implementing the, not really changing the OStream class, right? So we have now been able to use a functionality using the operator overloading outside the class, such that we'll be able to still use cout for printing the particular variable of your own user defined type, right? So in general, when we had implemented the left shift, so when left shift was implemented as left shift on number, like we discussed yesterday, it took one parameter. One was implicit, which was the class, and then the one parameter that it took was the integer. In this case, the left shift operator is outside, so there is no implicit parameter, and therefore we need to have two parameters being passed to left shift, right? So it's a usual binary operator. There needs to be two explicit arguments. And a similar mechanism, it's not specific, so that this particular left shift operator only can be implemented outside this class and so on. You can have plus operator, minus operator, postfix, prefix, etc. All these kinds of operators you can define outside the class, and then depending upon if it is inside or outside, if there is an implicit argument or not, you will have to define the appropriate number of arguments, right? So you can have all the other valid parameters, overloadable operators, you can also define them outside the class, right? So that this you should keep in mind. So I'm moving ahead to, for example, overloading of plus outside the class. So let me modify this example. So we have getNum here, and then there is a constructor, there is a private variable, and then I'm going to define an operator plus. So let's see. I have to rewrite this. So now we are talking about a similar operator overloading outside the class, and since we have the getNum function now, we don't really need this particular friend function to be implemented. So I'm erasing this off, right? And the way main is going to use this is num n1, let's say 5, and then std : cout n1 plus 3, right? And then return 0. Yeah, so this we can remove now. This is Java specific example, right? So the main is defining again num, variable of type num. It's going to invoke an operator plus on n1, which we need to define, and then return 0, right? So how are we going to implement this functionality is that I should have again an operator plus. Since it is outside the class, I am going to define it with two parameters, std : sorry, it takes num and integer as parameters, so not the OStream, some n5 and then integer x. And what does it do? Well, What we really want is that this part should return an integer which should be printed by the stdcout. So whatever is the implementation as far as n is concerned, I am just going to use that. So return n5 dot getNum, right? n5 dot getNum is of type integer. So I'm going to get an integer and then plus x. So what do we get? This is an integer. There is a plus defined on integer, which is the primitive type, right, which is supported by normal regular C++, plus integer, and therefore int plus int is going to give me int. That should be the return type of operator plus, right? So this is what we want to essentially get to, and this whole operator is going to return this integer which is going to be available here, and left shift cout left shift integer is defined, and therefore we are going to see whatever is the value that we have stored. Let's say 5 is stored, so 5 is 5 plus 3 8, so this 5 plus 3 8 is going to get returned, and this should print the value 8. That is what we expect it to do. The question here is, what is the issue with such a code, right? In the sense that there is some problem with respect to the logical processing of this code. This code, as far as this code is concerned, it compiles fine, it runs fine, it will exactly give you the expected answer, which is 8 in this case. But there is something which you should think about as we go along, right? So at this stage, I'll probably check if there are any questions, and if you have answer to that question, that what is the issue with this code, just post it on the question tab. From TKMKL, friend function can access the private data, so it violates the encapsulation property. What is the need for that, right? So this is a valid question. The friend function is not something which, so the question here is that the friend function is essentially able to access the private information, right? Which does not get into the, which is rather violating the access properties which are defined by the C++ standard with respect to the public, private and protected mechanisms, right? So then why should friend functions be really supported? So there exist cases like this where you would require a functionality where you might want to disallow the rest of the world from accessing your private members, but you want some unrelated class or unrelated function to be able to use the private information, right? So if there is if there is a specialization of the current class which wants access to the private members, then you better make it protected and let the derived classes access the private member, the protected members, right? So that is one way of implementing it. But in this case, for example, this operator is not even defined inside a class, right? It's a global function. In such cases, there is no way I can inherit these properties, and plus this operator plus or operator left shift are really unrelated functions. These are just doing one small processing. The left shift operator has nothing to do with the number class as such, and therefore there is no requirement of being derived from each other. So so in such cases, definitely the friend functions are going to be useful, which means that for most of all the use cases, you should have the private information, but there are very one or two specific operators or specific functions or specific classes which you allow them to access the private information, right? So in general, you can, again, as C++ allows, you can make everything as friend functions, and then essentially even if you have all private variables, all of them have essentially become public. But you should not go that far. Although C++ will not stop you from doing it, that doesn't mean that that is a good programming practice. As a good programming practice, the number of friend functions, the number of friend classes that you implement should be very minimal in number. Only when required you should do that. Otherwise you should get into what we also discussed, that friend functions are not really necessary if you have the public API specified, like getNum in this case. Then you don't really need to specify the friend functions, right? So that's a valid question. However, I would also like to mention a small technical aspect here. So the word that was used was encapsulation, right? The encapsulation does not really talk about this access methods. Encapsulation is just putting things together. So even in C, when we put things together inside a structure or a union, that is like encapsulation, right? So you are encapsulating, right? So you must have heard about the capsule which contains all the medicine, right? The powder and so on. So it's just putting things together. However, the one that you are talking about is data hiding. Right? Data hiding is slightly different or more than what encapsulation provides, which allows you to access certain parts of the method, certain parts of the class, and disallows you to access certain parts of the class, right? So that comes into the data hiding or data abstraction mechanism. Okay, so another question has come up from CTEU. Can operator overloaded functions be static? So this is an interesting question. So since you are talking about the static functions, essentially what this will require is that you cannot instantiate. So since you are talking about the static operator overloading, I suppose you are talking about the operators that are defined inside the class. And if there are there is a function which is defined inside the class, then how are we going to really apply that operator on an object of that particular type when no object exists, right? So for static functions to be accessing a particular the variables of a particular class, you need all those variables either to be static, or the class instantiation should not be a requirement for creating that particular for using that particular static method, right? So this is in general for static methods. And since the operator is defined on the class, in general there is a restriction that the operators need to be cannot be static, right? So it has to be a regular function. It cannot be. It has to be an object operator rather than a class operator, right? So the static members and static variables are essentially the class properties, whereas the usual functions that we have, get num, etc., these are object properties. So the operator needs to be object property. So I was asking about what is the issue with this code that we have on slide number 18, and nobody seems to have replied, but let me go to slide number 19, which has answer to that. So the slide number 19 says that in general, when we are talking about a particular variable, a particular operator, let's say plus, logically we know that plus is a commutative operator, right? Which means that you can do a plus b, alternatively you can do b plus a. So that is a logical implication, and since we are talking about readability of the code, when you can do n1 plus 3, you should also be able to do 3 plus n1, right? So when we are able to do n1 plus 3, well, you should be also allowed to do 3 plus n1, and it should actually give the exactly the same result, because the logic of plus says that it's a commutative operator. If you do not define, if you do not support this, then what is going to happen is that the compiler is going to check the first argument is integer, the operator is plus, and the second argument to plus is of type num, and there is no such thing defined, so I am going to result in a compile time error. So n1 plus 3 will compile and give the correct answer, whereas 3 plus n is going to give not compile at all. So in such cases, the way to handle this scenario is to have another operator which is essentially going to reverse the argument list. So operator plus now can take an integer, right? Plus it can take the second argument as num, let's say n6. And then what should it do? Maybe it should return n6.getNum plus x, right? So that is one way of doing. Alternatively, so maybe since it's really related to C++, I'll spend a couple of minutes talking about, let's say that I actually write it like this: return n6.getNum plus x. This will work. Now what will happen is that that plus is being defined with the first argument as integer, and second argument as of type num, and therefore compiler will find this particular template fitting the types, and therefore this function will get invoked, right? Or the code for this function will get generated. While this is okay, this will compile, it will give exactly the same answer as n1 plus 3. From the perspective of good programming practice, there is a problem. The problem is that now there is a repetition of this code. The meaning of plus is only 1, and that is getting replicated across multiple invocations of plus. So to address that, one way of doing it is to code reuse, right, which is one of the primary principles of software engineering, which means that whatever code you have written for operator plus when n5 and x were the two arguments, you should be able to make use of that in this function, so that tomorrow if you want to change the meaning, let's say you want to add a log function or a print function, tomorrow you will have to add it at multiple places, right? You want to avoid that. It should be possible that I just put it at one place and that should work. In such cases, you can make use of this existing function by doing n6 plus x. So return n6 plus x. What is n6? It's of type num. This plus is this plus, and what is x? It is of type integer. So that is num plus x. These are the two arguments that get passed. So tomorrow if something changes, essentially what you have is a single definition of, this is the integer arithmetic plus that is finally getting invoked from both of these functions. So this is a code reuse example, and that's what I have. But on slide number 20, so I'm going to also add arrows as to what exactly is calling what, right? So as far as n1 plus 3 is concerned, this is calling operator plus, this one, and as far as 3 plus n1 is concerned, it is calling the second operator plus. This plus that is being invoked from the second operator plus is going to invoke, let me put it this way, again this function, which is the first operator plus, and the first operator plus is actually invoking the integer addition. So this is the basic call which is going to happen. So what you see is really not what you get when you have operator overloading, in the sense that what can happen is that you might feel that there is this plus is essentially the, I mean, if you just look at it without looking at lots of types and so on, you'll feel that this is an integer addition, but it might not be. In fact, you don't even know that this is actually going to call another operator plus, right? And that operator plus is internally calling the base operator and so on. So there could be actually a hierarchy of operators which get called as you call a particular function or a particular operator, and therefore we need to be careful with respect to what you get is not always what you see when we are talking about C++ codes and operator overloading. Okay, so you should be careful about that part. Okay, so if there are any questions about this one, please ask. Otherwise, we will get into the scenes input parameters. Okay, so there is a question here from BMSCE. What will be held by this pointer in the operator plus example, right? So the question here is, what will this pointer hold when you are talking about the operator plus in this example, right? So imagine the case when I have, let's say, int main, right? And if I say that I'm going to do stdcout star this or this, what will happen in such a case, right? This is a global function. Similarly, this operator is a global function as well. Similarly is this. The pointer this is defined inside a method of a particular class, and therefore it is not accessible anywhere inside the global functions. And therefore, if this is a compile time error, accessing this here is also going to be a compile time error, right? So I hope that is clear, but if there is any clarification required, please ask. How can we overload the left shift operator of the same example. We just discussed overloading the left shift operator, but if you mean something else, please also. Okay, so one interpretation of that question could be that you have left shift operator being overloaded for cout, and then you want to overload the bit left shift operator for performing the integer addition, right? So that is possible to be done because the types are going to be very different. In one case, so this is an example of polymorphism where, okay, so let me, what we are seeing is that there is operator left shift which is defined with O stream and let's say integer, sorry. Let's say this is the signature of that with std added and so on, right? And then we are asking, can there be another operator, for example, for bit shift or whatever? You want to define a new functionality which says that I'm going to use num, which is being shifted by certain bits. So if you look at these two, the types are really very different. And if the types are different, then the compiler has, full information as to which function is going to get called. If you have that N5 left shift X, or maybe I'll say 5, then I precisely know that this is of type num and this is of type integer, so this is the one that is getting called. If I have cout left shift N5, then I precisely know that the other one is getting called. This is a question from BEC, overloading the left shift operator where right hand side operand is an expression involving object. Overloading the left shift operator where the right hand side operand is an expression involving an object. So are you talking about, okay, so let's see. Okay, so maybe what is being asked is N5 plus 3 or something. If that is the question, where the right hand side is an expression involving an object, right? So where N5 is of type num, let's say, and plus 3 is another, just an expression. So this is an expression involving an object, and that you are defining on cout. In such cases, what is it that you are returning out of this plus that is going to define if we need to overload cout or not? Right? So in this case, if that plus is being defined on num and integer, num and integer, and it is returning an int, there is no problem because cout is defined for integer. In case you have an operator which returns something other than int, let's say in this case I have a student class which is being written. In such cases, you have this part returning a student, and cout does not know about the student because it is likely to be a user defined class. In such cases, you need to define an operator left shift which takes OStream and student as the two arguments of that. So this is going to require operator left shift with OStream and the type was student, and it should return whatever. It should return typically OStream because you want to chain it, otherwise it can be void also. So this is so I suppose this answers what the question was, that the operand is an expression involving an object. So the return type of that, so even if this is an overloaded operator, that is okay, as long as it is returning something which is a known type for cout. If it is not a known type, then we need to define the operator left shift, otherwise we will get into a compile time error. There is a question from PSGCT, why the return type is a reference to OStream in the case of overloading left shift operator. So so let's see. So what we have said is that when you are overloading the left shift or the right shift operator, the return type should be OStream ampersand and not OStream. And you can try doing it in the on your with your compilers. but there is some internal state which the OStream object is going to maintain. So when we return only cout, you cannot in general do x equal to cout, where x is of type same as cout, and then say x left shift 5. That may not work, right? In fact, there is some internal state of cout which either cannot be copied, or it's going to create problem if you make multiple copies of that, because there is some buffer which we maintain inside the cout, which essentially is going to keep track of how many bytes have been written, and the next pointer's entry is the one where I'm going to add further bytes and so on. So this particular aspect is going to come into picture as soon as I remove this ampersand. If I remove the ampersand, then I'm making a copy of cout, and that copy if you invoke, so let me just give you that example. So what we are saying is that we have cout and then N1 and then N2, right, where N1 N2 are some arbitrary user types. If this invokes an operator like this is going to return a copy of cout. And on that copy, I'm going to define, I'm going to invoke the left shift operator, right? This is allowed because the type of copy of cout is also OStream, and that OStream left shift is defined. However, as far as functionality is concerned, the internal state of cout is going to get into problem if you make a copy, and it's possible that either you will see a garbage printed, or you might see that nothing has been printed if you make it as a copy. And we want in general to have the same cout object. Cout is an object, and we want only that cout to be used for all the printing, and therefore when we chain it up, we need to return a reference to cout so that it's the same cout object which gets used, right? So in this case, for example, in this case we will have to return OS. That's what we will have to do, and because of this ampersand, it is going to return a reference to OS, right? So that is implementation aspect of how the OStream object is defined, and in the books you will see that there is some internal state which is kept, which because of which this restriction exists. There's a question from, another question from PSGCT. Can operator function for left shift operator be declared as a member function of the class? So the operator function for left shift, can it be declared as a member function of a class? It's just any other operator, right? So plus, minus, left shift, right shift, and so on. So you can definitely define it inside a class. That is not a problem. However, what this will mean is, can it be defined here? Operator left shift, and there is some return type, and then it takes some parameter, right? What should it take? We should understand that this left shift operator, the way it is going to get invoked, if it is inside a class num, right? So then if I have a variable of type num n5 with some argument, the way this left shift operator is going to get invoked is n5 left shift and some argument, let's say 3. There is no mention of cout or something here, right? Because there is an implicit argument of the type num which needs to be invoked. So let's say that this has to be int x. If you define, for example, if you want, I want this to be something like cout, something related to n5, and therefore what I'm going to say is that I'm going to try this OStream followed by int x or something. There is an implicit argument of type num, and then there are two more arguments. The operator is binary, the arity cannot be changed, and therefore this cannot be considered as a ternary operator. So you cannot have 3 arguments, 1 implicit and 2 explicit. So this is going to result in compile time error. If you just give this, essentially that means that you support a functionality like this. N5 left shift cout, N5 of type num left shift, and then the explicit argument of cout, right? Why do you want to do that? Well, you can do this, but then you will have to define what it means, right? So in general this will be allowed, but then whether it makes sense or not, that you have to decide for your application, right? So putting it inside has its implications that the argument is going to get passed implicitly as the first argument, right? And therefore we cannot play around with cout type as well as the integer type, for example. Then there is a question from TKMKL. What is the difference between normal operator function and friend operator function? So maybe I'll repeat what I was saying. Outside the class, when we defined operator plus or something, any other operator, right, which takes, let's say, num as a parameter followed, so it will require two arguments, and let's say int x n5.n. This is that private variable which was here. This n5.n is referring to this particular variable n, which is private. This is an outside function, so there is some return type also, but I am ignoring that now. This is an outside function, this is not part of this class at all. In such cases, this function or this operator cannot have access to the private members of this class. And if that is the case, well, you are going to result into a compile time error. Now to address this issue, what you can do is to request the designer of this class that, boss, I want to access the private variable n from this function. So can you make this my function as a friend of your class? In such cases, you can say friend, whatever the return type, operator plus blah blah blah, essentially the signature of that function, which is going to give you, which is the class designer will say to the compiler that yes, this operator plus is my friend, and therefore this operator plus is allowed to access the private variables of this class. Right? So that is the difference between the usual operator function and the friend function. Okay, so I should also clarify one more part. In case your question was something like, if you have an operator defined inside the class, because an operator that is defined inside the class will have access to n. However, let's do it this way. This is possible to be done for, okay, so what this is going to give us is I will be able to say n5 plus 3, right? n5 plus 3 is going to use some information with respect to n5 and then some argument. This can be done both ways. For example, you can have, I'm going to ignore this friend for now. I can define a plus operator inside the class, right? Maybe that is your question. I can define a plus operator inside the class and access the variable n, and it can take a single argument which is of type integer. Perfectly fine, it will work, right? In case that is not supported, you can define it externally like this, where you can have operator plus, which is accessing a variable n5 plus n5.n plus x, right? So that is what it will do, where either this should be a public variable, in which case this code is fine. Alternatively, if this is private, then I need the getNum function. So I am not going to use getNum here. Sorry, I am not going to use n here, x, but I am going to use the public API that is supported. That is also fine, it will work, there is no problem. In case that getNum is not present and you are probably accessing lots of variables of this class, then you can request the class designer, or then essentially you can have a friend function defined inside, which then can be externally defined. But as far as functionality is concerned, there is absolutely no problem whether you define the operator here inside the class or outside the class, as long as the access restrictions are respected, right? So that's so you can implement it in both ways. One small issue which might come up, although I should also mention that, is that if you define an operator inside the class, that operator is going to get inherited when you derive classes from this class. However, if you define it outside, there is a possibility that this particular operator will be restricted to this particular type and the derived classes might not be able to take advantage of this. Right? So that you should be careful. There are also ways to circumvent that. For example, you can have a reference of a particular base type can refer to the variables of the derived types, or a pointer to the base type can refer to the pointers of the derived type, and so on. So if you can take care of that, that is also okay. But in general, it's possible that whether it makes sense to define the operator inside the class or not, this is a logical conclusion which the designer of this class needs to implement, right? So if I'm talking about a num, does it make sense to define an operator plus? Maybe it does. Then define it here itself. Why do you want to go outside? If it's something which later comes into the software cycle that earlier we didn't think of this particular situation, now there is a requirement that it should be added, but this code is very critical, we don't want to touch it as much as possible, then you can define it outside and the testing can happen depending upon the newly added code. So this is a question from TKMKL. What is the difference between normal? So this we discussed. So this is a question from GCT. It says that if overloading operation is 3 plus n, where n is the object, how to define the operator function inside the class? So this is where the problem comes. So whenever you have an expression of this type, x, let's say some operator plus y, right? This is an expression that we are talking about, it's a binary expression. Then the way it gets converted is that x operator plus, on that you pass y as a parameter. Right? So what we are saying is that there is an object x or whatever, the entity x dot, that is, it's a member function, operator plus y. Right? So if plus is defined on x, then we can apply such a processing. However, if we have x to be 3 plus n1, for example, where n1 is an object, then this x is essentially 3, and on that operator plus is not defined. Right? So we cannot invoke an operator which is a class member, right? This dot requires it to be a class member. This cannot be done for 3 plus n. Right? So this has to be done externally as overloading the operator twice, for example. As far as n1 plus 3 is concerned, that, as you rightly pointed out, it can be done either inside the class or outside the class. Do the built-in iStream and OStream classes have any friend functions declared in them? So I'm not sure what are the friend. There is likely that, so the question here is that the iStream and OStream classes, they are defined by the standard C++ libraries. Whether those have any inbuilt friend functions, there is likely that those have, but I am not aware of what are the friend functions that are defined. Right? So we'll have to probably dig it out inside the classes or maybe in some documentation. This is a question from BEC. Can we have operator overloading template function? Yes, you can have operator overloading along with the template function. So depending upon the type that you pass, you can overload a particular operator. So this we also discussed yesterday, where the template parameter is going to define what, so in case your operator is using that particular type, you will be able to use that parameterized type as an argument type in the operator, and then appropriate operator function can get invoked. Right? So this is not a problem. Question from PSGCT, is it possible to override an overloading function? Okay. Is it possible to override an overloading function? For example, for a derived class object to interpret an operator different from its parent class object, would this lead to any runtime errors? So I have never tried this, but okay, so this will require that, so what the question means is that you have overloaded an operator for a particular class. Let's say in this case num class, I have, let's say, overloaded the operator plus. Now can I override this inside the derived class? So my feeling is, so in case this is not a friend function, right? So this is a class member, the operator plus, and can you have a redefined functionality for this operator plus? To the extent I can think of, I think this should be allowed, although I have never tried it. So my feeling is that if you redefine this operator plus in the derived class, there shouldn't be any problem, right? And because the operator plus is essentially going to be treated like any other normal function. So according to that semantics, it should be possible to override it, but this needs to be checked. Would this lead to any runtime errors? That was another part of that question. Okay, so there is a case where there is a possibility of error, but that can happen in other functions as well, right? So for example, if this particular operator, so there is a base class and then there is a derived class, and both of them are defining this operator plus, right? And then there is a base class pointer which is pointing to either the base class object or the derived class object, and depending upon the runtime information, this can change. Now if you have argument being passed to these operators, internally the state that you invoke, right, the state that you access, this should be specific to that particular variable type, and if that state is getting accessed correctly, there is no problem. But if that state is not getting correctly accessed, I am not sure if that will lead to any problem. So I am not able to think of any runtime errors whether it will lead to, but you have some specific question on that, please feel free to ask, because I am not able to think of any situation where you will really need something more than what you require for regular functions. So even in regular functions, when you have function overriding in the derived class, then whether runtime errors can occur, I am not able to think of a good situation. But if you have a situation in mind, please post it on the question forum. I can as well share it with all the people. Why certain operators can't be overloaded? This is a question from SVEC. So there are probably varied reasons why these certain operators cannot be overloaded, as we were discussing yesterday. For example, the question mark colon operator is something which requires the first argument, the implicit argument, to be of type class, but it should also represent some kind of a condition. And this doesn't seem to be a very recurrent theme that you want your class to be representing a condition, right? So this is very special purpose, and therefore it probably doesn't make sense to provide functionality of question mark colon to be implementing to be overloaded. Similarly, the other types, for example, dot, etc., is probably going to be not very relevant if you want to really overload dot. So what will dot do? That is something which you have to define for, it should make sense also. So when you have x dot y, by overloading dot, what are you going to achieve? So there is a num class, right? So the way this is going to get used is that there is num variable n5 dot n. If you overload this dot, essentially that means that I am passing its field type as a parameter. By passing that field type as a parameter, I don't know what you are going to do differently, right? So that there doesn't seem to be any good usual logical reason. There might be very intricate cases which you can think of, which you can probably do magically to perform certain operation using dot, but that might not be the norm, and at least I don't see it as a norm, and therefore I don't think that it really makes sense to overload the dot operator and so on. Similarly, the scope resolution operator is useful when you are inside a function and you want to do you want to access certain variables in another scope and so on. So it's going to give you probably a cleaner information if you do not overload the scope resolution operator. Again, similar concept is going to happen. When I say std : cout, if I overload the : operator, I'm going to pass cout as a parameter to it. And if you have a type of cout as parameter, I don't know what you are going to achieve, because std itself doesn't seem to be, it's similar to a field inside a structure, right? So there is a namespace and there is an object inside it, or a function inside it. So it doesn't really make sense, or there aren't very good practical usage scenarios for which these need to be supported, and therefore my feeling is the designers decided not to support this overloaded operator. Okay, a few more questions. Can we override an overloaded operator in case it is derived into a child class? So that's what we discussed. This is a question from PCE. Can you override an overloaded operator? To the extent I can think of, I think this should be allowed because I don't see any reason why that cannot be overridden, because it's the overloaded operator is like any other function, right? So, and function overriding is supported, so the operator overriding should also be supported. Then there is a large question from BMSCE, the functions which cannot be made inline due to the presence of loops or other branching statements need to be defined outside the class. Is there any reason other than this that an operator overloaded function definition need to be written outside the class? Okay, so I thought we discussed a little bit about this one, that why do you require the operator to be outside the class? So when we were talking about an operator outside the class, it was not that the declaration was inside and only the definition was outside. There is nothing like that. This operator is actually a global operator. This is not defined with respect to a particular class. So that was the reason why we defined it outside. Right? There was no notion of inlining or unable to inline, having loops inside and so on. Right? This was not the purpose of this. So I would suggest that you go through some of the previous slides offline and try to understand that there is an operator which is defined inside, which takes the class type as an implicit argument. But this is not something which is always possible to be done. If it is possible to be done, well and good, but let's say the cout example that we talked about, you cannot change the implementation of cout or ostream, and therefore we need it to be outside. We cannot change couts or ostreams class definition. Alright, so that was the last question on this list, and thanks a lot for all these questions. This is what I was expecting yesterday. Yesterday the questions were less. Today they are coming good, and please continue that. Alright, so we'll go ahead with our discussion. So we are on slide number 21, and what we wanted to do is essentially scene also supports the right shift operator, and that is what we wanted to do. So for example, if I just change, okay, let me just write that down. That there is some num n5, let's say, and then I want to say C in right shift n5. For this, again, to be supported, we need a right shift operator defined inside in iStream. Sorry, the scene is of type iStream. In iStream, right shift operator with n5 as a parameter type, but n5 is of type num, which is our own class, and therefore it's unlikely that it will be there. What you already have is C in right shift 3, for example, sorry, not 3, x, for example, where x is of type integer. For primitive types, for standard types, already there is an implementation of right shift operator being overloaded, but for supporting the user defined types, we need this. So how do we do that? Well, essentially, instead of ostream, you just use iStream inside the operator. Let me define it here. So what we do is, again, it should return iStream object, reference to it, and then there is operator right shift, and what is the parameter it takes? The parameter it takes should be of type this is something which I am doing wrong. This should not be inside the class. The reason being that we need that the iStream to be the first argument. So that should be defined here, not inside the class. It should be outside the class. So iStream operator right shift, which takes now two arguments. The first one being the iStream, right? So this is a binary operator. So iStream, and then the second one is num, let's say n3 or something. Right? So there is an operator which is defined outside the class. There is no declaration of this right shift operator inside the class. The class per se, num class per se, has nothing to do with right shift operator. Right? This is totally externally defined. Imagine it to be a global function inside C or C++. So it takes two arguments. Since it is defined outside the class, the arguments need to be explicitly mentioned. So iStream and the num class. And inside that, what do? Well, you just take the iStream and use the right shift operator, which is defined for integers, and that integers is essentially n3.n. And for this to work, this should be public. So the iStream right shift n3.n, this should read. So the right hand side is now an integer. This n3 is of type num, dot n is referring to the integer type. So this one is supported, which is same as this one, where so this is allowed and this is allowed, and therefore now the right shift on num is getting translated into the right shift onto n3.n, right? So this is what I have when I'm talking about on slide number 21. So the slide number 21 essentially has, there is a bit of an issue on the slide because it does not define n to be, no sorry, I think this is okay. Yeah. So what we require is that in case this is not public, again exactly the same thing that we discussed about in case of cout, the left shift operator, is that in case there is a public variable, then you can do something like this, but in case it is not, then the compiler will issue an error at this stage, right, because n3.n is a private variable. But if you want this operator to be accessing the private variable, then we have to make it as a friend function. So friend iStream ampersand operator right shift, which takes iStream ampersand as the argument plus num ampersand as another argument. This is a signature of the operator that we have defined outside. Note that this is only a kind of declaration. This is not really saying that right shift operator is part of this class. No, it doesn't say that. It just says that this right shift operator, which is defined outside, is allowed to access the private variables. So that becomes a friend function, and then we are able to access this, and then the compiler goes ahead and accesses this. So this is what we have on this one. Is there on the slide 21? Is there something which we have missed? Yeah, so this seems to be fine. Right. So in case, okay, so one thing which we have not done is essentially that for chaining, you need to return the input stream, right? So that return is required specifically for chaining. If you don't want to chain it, then return can be void, and that should be okay. So then you will be able to do n6 and so on. Okay. So that is for the overloading with respect to scene, and then you can combine left shift and right shift operator arbitrarily. So yeah, I'm going to take up the questions a little later. Already there is one question, and feel free to ask more questions. So what we will do now is that we will combine the left shift and the right shift operator, and whether it is possible to write both of these for a particular implementation. Yes, in general it is definitely possible to write, and that is what slide number 22 is suggesting. But in the discussion, let's see if something more comes up. In case you have more questions which come up, you can always add that to the questions tab. So here we will have, so I'm going to now not worry about main. Instead what I will do is there is a friend function here. I'm going to add another friend function, oStream, which is the operator left shift, which takes oStream as parameter. Similarly, it takes num as the parameter. Right? So there is a friend function which is the left shift, there is a friend function which is the right shift. The right shift operator is already defined. Let me define the left shift operator here. So that is, which takes O stream OS and num ampersand of n whatever 2. And what this should do is essentially it should invoke our C out. Right, so here we will require std : O stream and so on, or using namespace std, but I'll just ignore that. And it should invoke it on n2, that is the num dot n. So you want to read it inside that. And this is possible to be done because the operator left shift is also a friend function, therefore you are able to access the private variables of this class, right? So this overall example tells you, even if you do not have this getNum function, you will be able to access the private variables because of the friends. And this overall example tells you that you can overload multiple operators inside the same class and so on, right? Or for a same class. So typically when you have any other type that you define, let's say student or a car or an automobile or whatever, department, institute or some particular factory and so on, or a library, you can define all these C in, C out. So you can use variables of those types in your C in, C out, but you will have to define those in this particular manner. So this is quite a standard mechanism. Now it has become a standard mechanism to use friend functions with respect to the operator right shift and left shift, which you can utilize for the purpose of implementing the IO functionality using C out and C in. Because if you do not have that, if you do not have such a flexibility, the way you will have to print is essentially going to be that I have n5 and then I am going to say n5.print, or I have n2 and I am going to say n2.read. This is one way of implementing it, right? So you can have the read functionality, the scene kind of functionality, using a separate read function. And then you can have the print functionality, the left shift functionality, using another, let's say println or whatever method that you want to do. This is possible to be done. However, if at all you want to use C out for printing, which is a very natural, logical way of looking at it, because that is how we study input-output functions in C++, then this comes to rescue. However, when you compare these two, you realize that this is just a readability issue. As far as functionality is concerned, you can get exactly the same functionality just by implementing another function. Right? So this should be kept in mind always, that operator overloading is primarily for better readability. Alright, so if there are any questions, we can take those up now. Otherwise, we'll move ahead. Yeah, so there is one question here. How do we call superclass version of an overriding method in a subclass? Right. So this is not something which is related, but anyway, so what you could do is that essentially you need to use the scope resolution operator. So this super is something which is provided as a keyword in Java, but it's not there in C++. But what you could do is that you can use the let's say star this. So let me just write down properly. So inside the operator of a particular class, when you access star this, it is going to refer to the current object, right? That current object you typecast as the base class. Once you typecast it as a base class and use a scope resolution operator to call a particular function, that function, even if it's overridden in the derived class, since you have typecasted it, you will be able to access it as of type the base class, and then when you invoke the function which is overridden in the current class, this, still you will be able to access the function which is there in the base class. So that is possible to be done in C++, but in general, if you really require that, then that does mean that you don't require an overriding. Right? So the whole purpose why overriding was done inside the derived class is because you didn't want the functionality of the base class. So, but there exist situations where you might really require that I want to override this function also, as well as reuse some of the functionality from the base class. In such cases, such a flexibility is given where you can use such functions. All right. There is a question from BMSCE. Can operator overloaded functions be used as member functions? Can operator overloaded functions, if those are part of the class, well, those are member functions. If those are not part of the class, no, you cannot use those as member functions. That's as simple as that. So imagine, so I would suggest that you should look at an operator which is defined inside the class, consider it to be very similar to any other method inside the class. So whatever is usually possible with that method, with the method of the class, it should be possible with that operator also. And if there is an operator which is defined outside the class, imagine it to be any other method, any other function which is outside the class, a globally available function. And whatever is possible with globally available functions, the same should be possible with an operator which is defined outside the class. So it should be viewed exactly like that. Right? All right, so that is all the questions that we had so far. So let's move ahead, and I am on slide number 23, and what we want to do is to do some more magic into the operator overloading, where we not only wanted to talk about the input output, but we also want to overload some of the other operators. For example, as we were discussing yesterday, there are cases where you are not happy with the current memory allocator. You want to have your own custom memory allocation done. Right? For example, when you do a malloc, it's not guaranteed from which area the memory is going to come. Right? So for example, there are database applications where you need the performance to be paramount, and these different database applications cannot be dependent on a particular operating system functions to really manage memory. So what these database applications will do is that they'll collect a lot of memory from the OS, right, using, let's say, a large malloc or calloc or some SBRK function system call or something. And then once they have obtained a large chunk, the database application itself will manage different parts of the memory. So different sub-applications inside the database applications, whenever they require memory, whenever they need memory, the database application, the allocator inside the database application will allocate some memory out of this big chunk that it has obtained from the operating system. Now for this to happen, the memory allocator needs to take care of all of these mallocs and frees and garbage collection probably and so on, right? So all of these come into picture when you are accessing a particular memory location, whether that is valid or not. Either that can be handled inside the database application, which is likely to be the case, or if it leaves it to the operating system, well, that is also possible to be done. But then, since the chunk was obtained by the same application, and if a sub-application is accessing a memory which is outside the allocated range, but inside the OS allocated area, it's possible that you might not see any dangling pointer or seg fault and so on. And that can actually create problems. So all these checks need to be done probably inside the database application which is managing memory. When you are allocating and deallocating memory, sometimes some of the other issues come up. For example, if, so let's say this is the whole memory which is managed by the OS. When your database application asked for, maybe it allocated certain memory to your database application, database management system, right? And maybe it kept the rest of it. This is not really a correct way of interpreting this, because there is a tertiary memory, the virtual memory that comes into picture where, and this is divided into different pages, and then all of these pages will get loaded on demand and so on. But this is a simplified view. For the purpose of our understanding, this suffices. Let's say that this is one area which is obtained by the DBMS. And then there are different parts of this DBMS application. So since we are talking about memory, let me put the applications differently. So let's say that there are these different parts of the application which are requiring certain memory. Right? So it needs some memory, this needs some memory, this needs some memory, and so on. So let's say that it is allocating some area. In general, the allocation of this memory can happen arbitrarily within this area, right? But let's say that this particular sub-application 3 is accessing inadvertently a memory area here. This memory area is not really part of the one that was assigned to 3, and therefore there is a problem. However, the hardware will not detect it because this is still within the boundary of what DBMS obtained from the OS. Right? So all these checks need to be added. Now another issue that comes up is that how should the memory be returned, in the sense that let's say all of this memory is initially free, and this particular application 1 needs a large amount of memory, let's say this much. Right? And then the second application comes, it also requires a large amount of memory, let's say this much. So this is all required by the second application. Now first application, sub-application gets over and it frees this memory. So this memory area is free. Right? So let's say that, just for the sake of our example, this is 2 MB, this is 1 MB, this remaining is 1 MB. Now application 3 comes and it needs 2 MB of memory. Right? Typically when we ask for memory, let's say using malloc, we expect that the memory that gets returned is a sequence of contiguous bytes, which means that if I need 2 MB of memory, it cannot be coming as 1 MB from here and 1 MB from here. So there is memory which is available, 2 MB of memory. However, the allocator, memory allocator, will not be able to give this memory to application 3. The malloc will fail because this is fragmented. There are ways in which you can circumvent this. For example, you can move this area here and you will have to go back to the application and manage it in some way, or keep track of some kind of mapping from pointer to the area and so on. But the purpose of this is that if you do not get into those complicated mechanisms, in general, the ordering in which you allocate memory is going to matter for your application's performance. Right? Alternatively, you can say that no, I don't have enough memory available, then this malloc is going to fail, and then it might try again later, or we will just discard that whatever operations it wants to do on memory deallocation, the malloc error, it will continue with that particular error. Maybe it will exit. So this needs careful consideration with respect to how the memory should be allocated. For example, if the memory would have been, just for the sake of this example, it need not always work. So initially we had allocated this memory. When the second application came, if I had allocated this 2 MB of memory here, right? So this is now 2 MB, that is 1 MB, now 1 MB is free. Now when the first application finishes, this memory area is gone and I have 2 MB free. When the third application comes and asks for 2 MB memory, it succeeds. Right? So the ordering in which the memory allocation gets satisfied, that is really going to affect how the memory is going to get utilized. Right? Even the utilization matters, and overall application performance is definitely dependent on that. So there are mechanisms in which you can talk about how do you allocate memory. So there are primarily 3 mechanisms. First fit, the first available memory, which essentially what we did, that is sufficient for serving the purpose that you give. The best fit, so the smallest one fitting request that gets allocated, and the worst fit, where the largest available memory area that gets returned. Right? So this is something which, these are really heuristics, these are algorithms, but these are still heuristics which get used in memory allocators, right? And there are more complicated ones which people use depending upon the profiling mechanism and depending upon how the micro benchmarking done for different applications and so on. So the reason for giving this motivation is that there exist ways, there exist situations where you might require a different way of allocating memory. Let's say your memory allocator is using first fit algorithm, but you want to change it, you are not happy with it and you want to actually use the best fit or the worst fit. So in such cases, you do require memory to be managed on your own, and if you are stuck with malloc, well, you don't have any control over how the memory is going to get used. So in such cases, C++ allows you the mechanism of overriding this new and delete, right? So new and delete are operators which are for memory allocation and deallocation. So maybe at this stage I can ask this question that, see, C++ also supports malloc and free. Why does it require new and delete, right? It could have actually gone ahead and supported malloc and free itself. And why do we really require a new operator or a delete operator to be additionally given in case of C++ specification? Right, so that is some question which you might want to answer at this stage. Alright, so with that motivation, let's go ahead. Let me check if there are any questions so far. Okay, there is a hand raise from SVEC.
So
yes.
What is the main difference between using references and pointers as return type?
So the question here is that what is the difference between using references and pointers? So as far as well, it's not really specific to return type. You can as well talk about what is the difference between references and pointers being passed as parameters. So it's not specific to really the return type. But what it essentially says is that, for example, in C, you support pointers. Right? There is no notion of references because everything is passed by value. When you have pointers and you need to pass a particular variable as pointer, which means that you need to pass address of that variable, inside the function you are going to access it as essentially using the arrow operator or something, right? So, or a dereference of that variable, how good your code looks like, right? So a typical example that we give is that you want to swap, let's say, two variables, int x and int y, sorry, right? And a typical mistake which people do, at least the students first timers do, is like this. And then how do you call it from main? Well, you can just have int a equal to 3, b equal to 5, and then we say swap ab. Right? This is one wrong way of implementing swap. And then you can print the value. So you can have a printf before swap and after swap and check the values of AB, and then students will get surprised that, oh, the values of AB are still the same, 3, 5 and not really 5, 3. And the reason being that there is pass by value happening here, right? So to change that, then you get into the pointers that you need to pass them as addresses, specifically in C, or you can do it in C++ also, and then these become pointers since you are passing it as an address. And then the way you will do it is that, well, you will say star x and then star x equal to star y and then star y equal to t, right? And then you look at this function, and earlier the function was at least something which was easy to understand, better readable. Now suddenly when you look at it, suddenly there are lots of stars, and in general when you look at functions with pointers and so on, you will have lots of stars and arrows and not able to always figure out exactly what is happening and so on, right? So although the functionality wise you will be able to achieve exactly the same thing, it looks a little odd as to how, what exactly the code is doing, etc. Right? So you need to actually go through it very carefully to understand. And as we all know that many of the seg faults and memory related issues happen via usage of pointers, right? And some people actually hate pointers a lot. Sorry, is there a question? All right, so in contrast, if you have pass by reference as a mechanism, how does it help, right? So pass by pointers, you are able to access it via dereference, right? That should be clear. But let's say that a language like C++ supports pass by reference. What this means is that you have swap AB as it is. I don't need to really get into ampersand of A and ampersand of B. And then here, instead of specifying the stars, I'm just going to specify that this is pass by reference. And then the code remains the same as it was earlier. So whenever I'm referring to X here, I'm actually referring to the X which was passed here, which is A, and Y corresponds to the usage of B. So this is a very nice mechanism. Now the code is again clean. There is some additional mechanism I need to put in terms of the the parameters, the types of the parameters which I have. As far as the call and the code is concerned, it remains exactly how pass by value looks like. And this definitely is much more readable than the pointer based code. And in general, you can talk about such a thing about most of the codes that we either with pointers or references. Internal implementation of all of this references versus pointers is actually going to be the same. Internally, if you will notice, if you look at the assembly code, you will realize that pass by reference will actually pass the address of A and address of B, and internally it will have to dereference those variables so that you get access to that particular memory location. So internally, implementations are going to be the same for references and pointers. However, looking at the code for a programmer, this becomes much cleaner way of implementing, right? A similar thing is exactly happening when we are talking about references being returned as, so variables being returned by reference or variables being read by reference, right? So I suppose that answers the question. Is there any other question that, all right. So thanks for that question. However, I should also mention that it's not always the case that you are worried about readability when you are passing arguments as parameters as references rather than by value. For example, let's look at this particular example. As far as this num is concerned, it's not really necessary that you should pass it by reference. As far as this N3 is concerned, it's not really necessary that you should pass it by reference. The reason being, you are not really writing to it. Well, sorry, in this case you are actually writing to this, but where we had the left shift operator, let me quickly change this. So the left shift operator implementation here, okay, so let me focus attention on this one. Right? So the left shift operator is going to read the value of n from this num type variable, and it is going to print it onto the cout or the O stream. I really don't need to write to that number variable, right, or this variable n, private variable n inside that num. But still I am passing it as by reference, reason being that the objects are much larger in size, right? So you might, in this case it's probably a single variable inside it. But in general, the classes and objects or the structures and objects might be much larger, and that is the reason why you are using those aggregates. Similarly, arrays, right? The purpose why arrays were passed by as pointers rather than by value in C. The reason was that otherwise there is a lot of copy code which you need to generate for passing array arguments. So similarly here, the set of bytes that a structure or an object requires, you don't want to copy all of that all the time, and therefore from efficiency perspective, passing it as a reference or passing it as pointer turns out to be more efficient. So that is one reason why we have used references. All right, so there is one more question from PSGCT. Answer to the question you asked, new allocates memory from the free space, whereas malloc allocates memory from the heap. Okay, so that seems to be, okay, so the question I had asked was that why do we really require new? Why can't we really use malloc? So the question's answer that is suggested here is that new allocates memory from the free space, whereas malloc allocates memory from the heap. right? So I don't understand what that free space is, but essentially memory is kind of, I would say, divided into multiple parts, and two of the important parts are, one is stack and another is heap. Stack is being used for different invocations of functions, local variables, etc. And the heap is essentially gets used when we are talking about malloc and free. As far as new is concerned, new also uses heap. It doesn't use any other free area and so on. That heap itself is the free area from where the allocation is going to happen, right? But if that is the case, then why do we really require a different kind of operator for C++? And the reason is that we need constructor to be invoked, right? When we allocate memory using malloc, that is just going to allocate some memory. We just do p equal to malloc 10, and that is going to create 10 bytes and return a pointer to it. It's not going to do anything with respect to the class that we are invoking the malloc for, right? So when I say that, let's say num, right? So num star p equal to malloc, let's assume that the typecasting is done fine, and then I'm going to do size of num. So I have created a memory area, right, which is of the same size as num, and I'm allocating that memory and returning its pointer to p, so p starts pointing to that memory area. What has this done? Well, it has done nothing with respect to num per se, except for the size. But when we are talking about, let's say, q, num star q equal to new num, well, let's say that there is a default constructor and so on, or it's okay, we can give that argument. What we are saying is that new is not only allocating that much space. In this case, it's also invoking the constructor. Even if there is no constructor given here and there is a default constructor supported, in such cases, the constructor automatically is going to get invoked. That is not going to be done by malloc. And why is constructor invocation important? Because you are initializing some data members there. In the initialization, if the data members are not initialized, then the rest of the processing that you do with p, let's say I do p arrow x plus plus, something like that. If x is undefined or x is not initialized, this value is going to be garbage, and that is going to lead to some arbitrary processing in your code. Whereas if you do q arrow x plus plus, where q arrow x is initialized to 0 value, then that is correctly going to get incremented with 1, right? So that is something which we need to keep in mind when we are talking about malloc and new. And similarly, free is not going to invoke the destructor, whereas delete is going to invoke the destructor, right? So that is an important point why we require new and delete operators, and not malloc and free are sufficient. Okay, so there is an interesting question from CTEU. Can malloc, calloc can be overloaded as in function overloading? So can you overload malloc and calloc functions? Yes, you can do that, because these are like any other arbitrary functions which are there in C++, right? So you can do that. However, there is a problem. The problem is that for overloading, you need the types and the number of types or the number of arguments to be different. So as long as you can support that, you will be able to overload these. Although I have not tried it, but I don't see any reason why this will not be supported. Okay. So that was an interesting question. So we'll move ahead with, okay, so we are almost close to our time. So what we'll do is we'll probably break here, but let me summarize what we studied today. So what we are saying is, what we looked at yesterday was basic operator overloading. Today we focused a lot on overloading of operators for the input-output functionality, specifically the left shift and the right shift operators. And then there were lots of issues which came up because these operators cannot be defined inside the OStream or iStream class, so we had to define them outside. And when we defined them outside, we didn't have access to sometimes the private information, so we had to get into the usage of friend functions and so on. So this mechanism is something which you should remember. So you should not blanketly think that friend functions are the ones which are going to give you the left shift and right shift functionality. No, only if the public information is insufficient and you need private information of a class, then you need to get into friend functions. Otherwise, you can define the left shift, right shift operators very easily. And not only left shift, right shift, but plus, star, any other operators you can define externally as long as the parameters are passed correctly, right? So that is something which you should definitely try out. I would also recommend that all of you try this out. I mean, you must be going through object-oriented programming as a course and or C++ programming as a course. And although conceptual aspects can be taught in class, there is a lot which needs to be learnt while dirtying your hands on the machine. So I would strongly recommend that you try these out examples, and there are lots of nice tutorials online, or there are books also. Just go through them, type out certain programs and ask yourself some questions and try those out as well. Well, you will get into compiler errors and so on. Initially the compiler errors will be non-decipherable, but as you grow or mature inside C++ programming, you'll be able to make use of them, you'll be able to understand them better, right? So with that, we will stop for today and we'll continue our discussion on new delete operators and other remaining parts of that we have planned for this course. Plus, we will try to discuss some of the questions that I have posed as part of the quiz, which you might be able to see on the QEEE portal. So we'll discuss some of those questions also if time permits tomorrow, right? See you.